The last part of this lesson is we need to be able to write piecewise defined functions when given the graph. So example 6 says the graph of a piecewise defined function is given. Write the definition for the function that best describes the graph. Now, luckily for all of these ones that you're going to have to do, all parts of these are going to be linear. So what we need to be able to do is write this in our y equals mx plus b form. So I need to be able to find the slope, which is rise over run, and I need to be able to find the y-intercept of that graph. So this first one here, we need to, you can see here we have a negative slope, then it stops, and now it has a positive slope. So let's find the equation of this line first. First thing I need to do is find that slope. So shouldn't have circled that. Okay, slope is rise over run. So from this point here, we are rising 1, and oops, nope. We are rising 2, and then we are running not positive 3, but negative 3, since I'm going back to all these negative numbers. So if my slope, I'm going to write that over here, is rise over run. My rise is 2, my run is a negative 3. So we have negative 2/3 x, that's my mx, and then where is my b at? It's crossing right here at 0. So if you want to write in, let's do it in pink. If you want to write in a plus 0, you can, but if you want to leave that off, that's also fine. Okay, now where are we using this graph of negative 2/3 x? This one here starts at negative 3 and it ends at 0. So this is from negative 3, closed circle, so less than or equal to x, closed circle, less than or equal to 0. Now let's talk about this graph over here. This graph, from point to point, and I always start at the bottom and go to the top, but it doesn't matter. This one is rising 3 and running 2. So my rise over run would be 3 over 2x. Again, that y-intercept is at 0, so you don't need that, but if you want to write in a plus 0 here, you can. And where are we using this line of 3 over 2x? It starts at 0 and it goes to when x is 2. Now, even though this has a closed circle here, I have already included that 0 into this one right here. So I'm going to write this one as 0 is less than x, and then all the way to 2, which is a solid circle, 2. For this to work, you cannot include 0 in both, but it also, because they are on the same point, it does not matter where you include that 0 at. So if you wanted to make this one a less than 0, and then this one 0 is less than or equal to, that would be the exact same thing. You just cannot have it in both of them. Okay. If you want to, you can try pausing the video and seeing if you can do this one on your own. Okay, so let's either continue on or let's check our answers here. So for this first one here, it looks like I have another point right here. So my rise is 2 and my run is a -1. So if my slope is rise over run, we have a slope of -2. So you got -2x. And then this time we do have a y-intercept. Where is this graph crossing that y-axis? And it's right here at -1. And so slope up 2 over -1. 2 over -1 is -2. And then it's crossing the y-axis at -1. Okay, so now this line here. Oh, first, okay. And then where is it happening from? This one goes to infinity and starts at, or ends at 2. So we're talking about every number that is less than 2, and because it's a solid circle, or equals 2. So when x is less than or equal to 2. All right, now let's jump to this. We need to evaluate the slope. So it looks like we have a point here and a point here. My rise is 1. My run is -1. Okay, because again, going to the left. So -1, or sorry, 1 over -1 is -1, or just -x. Now, even though I can't see a y-intercept, I have to know where it would have been if my line's domain wasn't restricted. So if my slope is 1 over -1, if I keep going up 1 over 1, here's the next point. Up 1 over 1, here's the next point. Here is where my line would be if it wasn't restricted. So that y-intercept would have been right here at +4. If you don't say that that is at 4 and you just say -x, that shifts that whole line down, because then they would have the y-intercept at 4 starting down here. So you still have to have that, even though it's not touching it. And then where is this one happening? Well, it's starting at 2, and then it's going to keep going forever, meaning it's going to go to infinity. So this one is when x is greater than 2, but not equal to, because of that open circle. So when x is greater than 2.